Hello, it's Travis from Zero Industries. So today I just wanted to go over 3D printers, particularly when we have metallic dust. So we've had a lot of inquiries that have come through lately concerning 3D printers, particularly within the research and university areas. They provide a series of challenges that we have to address. So one of the problems that we see coming through is we will have a manufacturer who will say our device is compliant, and then people will purchase it and bring it in, and then they'll start to look into what the requirements are, and it will give a broader expectation of what's missing. And what we mean by that is we just see, for example, that here on the screen now, you can see everything relating to the function of a 3D printer from start to finish. Now, this has nothing to do with the dust extraction system that has its own series of challenges, and nor does it have anything to do with what happens after the build job is complete and it's taken off its build plate and out of the form itself. So when we go into it, we're going to isolate all of the areas that we need to make sure that we've got addressed. So with your virgin powder, particularly if it's a metallic or it's a combustible, you need to make sure about how you're handling that virgin powder as well. So you've got it isolated in its own storage area. It has a potential equalization to it. You have it monitored correctly. You have it identified within a manifest. All of those scenarios around the virgin powder. When it comes into it, you might have a blending station that will create a combustible dust. When it comes into its drying section, whether that's within a closed powder loop or that is handled externally, so you're only dealing with one product, you're dealing with one product entering into the powder hopper that enters into the 3D printer. Now, if you do blending, drying and anything about sieving and recycling your powder, you need to make sure particularly, and we're only dealing with combustibility aspects here, to make sure that it's compliant with the 60079 series, within the NFP PA 6060 series. You're doing a dust hazard analysis, you're doing a dust containment study, you're providing a hazardous area classification, you're providing all of those structures around those requirements that make it possible to operate it in a safe way. If you're doing all of that, then you need to have that process defined quite well before some consultant can come in and you can engage them to do the hazardous area classification, the equipment selection, the dust hazard analysis, the dust containment study, whatever their scope of services are. When we come into the powder hopper that comes into the 3D printing equipment, then once that is complete, typically they run under an inert gas. So you just need to make sure that that's well documented and that's getting calibrated correctly as well. Then here you can see here that it will go into your build frame, that you'll have your build plate and you'll have your build job. So as you can see here, there's an inert gas around that. That will then go into your unpacking and depowdering. Your build frame will come out. That will go back into the refurbishing process with your build plate. As you can see, build frame comes out, you have everything on your form, you have your form and your build plate there, that then gets cut off. Your build plate then goes to a prep bay, whatever that is, and then your build plate goes into refurbishing and back into the assembly with your build frame and back into the 3D printer. So as far as the hazardous area requirements and DHA requirements, that happens within this particular section here, your process about your blending and drying. This will happen within your 3D printer from your powder hopper and while it's printing as well. You're unpacking and depowdering as well. Typically that's under some form of positive pressure or negative pressure, depending on the device that you've got, whether it suctions it out or whether that's a manual system. then that will then go into your build job. Now, once we go into the build job as well, what we're seeing occur is the build job will then go into a workbench. The workbench will have its own extraction system. That extraction system, typically we see it multi-manifolded, and we don't like seeing that. We like to see that separated on the same manifold, or a separate manifold to its own dust collector unit, or the same dust collector unit from the 3D printer. Then it's up to the organisation to make sure that if it is a multi-material device, that they're then being able to allocate what happens when you've got dissimilar metals or dissimilar products, so that you're not having a chemical reaction occur within your bag house. So if that is the case, there are ways to do that. But once it gets onto the workbench, and if there are form bays that are required for it, you've got a series of challenges with the form bay, because you're no longer introducing explosive dust cloud. You're introducing an explosive gas cloud from the alcohol, isopropylene, or any form of cleaning agent that's being used, and typically they're all an ethanol-based agent that you're using within that form wash, that will then wash the form, agitate it, then it will go back onto its workbench for final milling or final sanding or wet sand, or whatever the requirements are for that particular form. Goes back into your form wash for its final pass, and then it's ready for its application, whether it's going to a surgical team, whether it's going to a research facility, whatever it is. That's what we're seeing occur. So how we're doing it from a broad stroke is we're going classify your 3D printer, classify your production area here. So you'll have zone 20, 21, 22, depending on your material. Have your materials, have a combustibility report done on your material, and done on any blending that you have as well. So if it's a blended material, then have that particular blend analysed. Then you'll have a separate area for your 3D printer, then also your your workstation as well, and putting some form of hood on where you're sanding or milling or whatever the operation is for preparation, and then having either a downdraft system for the form base. So what happens is when it fills up, it's diluting the atmosphere around it, because those form bays, what we've seen, they're not EX rated. So it's a case that you've got a non-certified device within a hazardous area. So the only way that we can see doing that is by increasing the ventilation and protecting that area by EXV. And then underneath that as well, where the connection point goes, we then suggest that you pressurise that particular area, because it has a connection port for your manifold for the additive that goes into your form bay, with, as I said, whether that's ethanol or some other alcohol-based cleaner. So those are the complexities that we're seeing. Thought I'd do this quick video, provide everyone a bit of a rundown from a high level about what needs to occur, the trends that we're seeing in the market. But it's good to see that this technology is being utilised and there are ways to get it done safely. Thanks, guys. I'll talk to you soon. Bye.